quadratics in standard form. All right, in case you do not remember standard form, let me remind you. Standard form is y equals ax squared plus bx plus c. Where a is still going to tell you whether it's a flip, compress, stretch, right? In order to find the vertex, I gave you a little equation back in Algebra 1. I told you never, ever to forget it. You guys forgot it, didn't you? Okay. All right. Find the vertex. First, to find x. First, to find x, we do negative b over 2a. All right, so whatever those coefficients are, we're going to plug them in. That's going to give us our x value. Second, to find y, plug the negative b over 2a in. That's going to give us our vertex. That is the only thing different today, is that's how we got to find it. That's it. So here is example number 1. We're going to find the vertex. And of course, if I can find the vertex, that means I can find axis of symmetry. And if I can find that, and looking at my equation, I can also find whether it's a min or a max. And of course, if I know all that stuff, I also know domain and range. All right, so here's my equation. Let's go with y equals x squared minus 4x plus 1. All right, so the first thing we're going to do is find the vertex. I'm going to remind you that the coefficient in front of x squared is my a value, the coefficient in front of x is my b value, and this one on the end is my c value. The first thing we have to do is do negative b over 2a. So in this case, I have negative. My b value is negative 4 over 2 times 1. Or 4 over 2, which is 2. Very good. All right. So then to find my y value, I have to take the 2 and plug it back into my equation. So I have y equals 2 squared minus 4 times 2 plus 1. So right here, 2 squared is 4. Negative 4 times 2 is negative 8. So 4 minus 8 is negative 4 plus 1 is negative 3. All right, so I have a vertex at 2, negative 3. Any questions with that one? We're all good there? Okay. Well, if I know my vertex, I know my axis of symmetry is x equals 2. Looking at my a value, it's positive. So since it's positive, it opens up, so this is a minimum. My domain, of course, is always negative infinity to infinity. Very good. And my range. Since this opens up like this, we start at the y value, which is negative 3, and it goes to infinity. Anytime it's a minimum, you start at the y and go up. If it's a maximum, you start at negative infinity and go to the y. Okay? Does this look familiar? A little bit? Good. Good. It is in there. We're just going to pull it out. We got this. Well, of course. Let me do one more example here, and then we'll do some graphing. Example number 2. All right. So on your worksheet today, 1 through 6. Find vertex, axis of symmetry, max or min, domain or range. And let's go with y equals negative 2x squared plus 8x plus 1. So again, I'm going to start by reminding you that this is my A, this is my B, and this is my C. Just don't want you to forget that. Don't even ask. Don't. We have sand and shoemaker land, and we're good. Okay. So first, we're going to find our x value, which means we do negative b over 2a. So we do negative 8 over 2 times negative 2. Or negative 8 over negative 4, which equals 2. Now to find the y value, what do I do with that 2? Yes. Very good. So we're going to plug it in here. I have y equals negative 2 times 2 squared plus 8 times 2 plus 1. This is 2 squared is 4 times negative 2 is negative 8 plus 16 plus 1. We get 9. We absolutely do. So we have a vertex at 2, 9. We have an axis of symmetry at x equals what? 2. My first term, or my a value, is negative this time. Is this a max or a min? It's a negative. Right here, see it? It's a negative. It's a max. My domain then is negative infinity to positive infinity. And my range, because it's a maximum, it opens like this. It starts at negative infinity and goes to my y value of 9. All right, so any questions on these first 6? Okay. So the next 6 is graphing them. It's not any different than what we did yesterday. You plot your vertex, you sketch your axis of symmetry, you pick 2 points to the right or the left, and you reflect. Same exact stuff. Okay? Do you guys want sticky graphs, or you just want to do it in your notebook? Probably going to do 2. We're good? Do you want sticky graphs or no? Yes? Okay. Let me get those out. Madison is serenading us over here.
Oh, no, that's not what I said.
Well, that's good. Oh. There you are. Yours is?
Yeah, I got butchered yesterday.
Oh. Did you help with that?
No?
Ben, here you are. You're welcome. There you go. Okay. Here we go. Let's go with example number 1, or number 3, I guess it is. Sorry. Example number 3. Go ahead and put your sticky graph in there. Yep. Told you today was easy. Didn't I? All right, example number 3. And again, don't forget, make sure your y is to the sky. All right, let's go with y equals. Because I know there's going to be questions out there, we're going to start with 2x squared minus 3. All right, now in this special one, again, this is my A, that's my C. So what do you think B is? 0, awesome. All right, so first we do negative B over 2A. Means we get 0 over 2 times 2, or 0. That's my x value. To find my y value, I'm going to plug that in. negative 3. Y equals 2 times 0 squared minus 3 gives me negative 3. So I have a vertex at 0, negative 3. I have an axis of symmetry at x equals 0. 1, 2, 3, right there. And here's my axis of symmetry. Now I'm going to pick 2 points. So I either want 1 and 2 or I want negative 1 and negative 2. 1 and 2, absolutely. We're going to plug them into our equation. We have 2 times 1 squared minus 3. 1 squared is 1 times 2 is 2, minus 3, negative 1. And then I have 2 times 2 squared minus 3. 2 squared is 4, times 2 is 8, minus 3 is 5. So I go over here, I've got 1, negative 1, 1, negative 1, and 2, 5. 1, 2, 3, 4, 5. Now that I have those points there, what do I do next? We reflect them. So 1 here, and 1 here. And then we try and connect our dots. All right. Any questions regarding that? No questions? All right, let's do one last one. That'll be good. Here we go with example number 4. Put your last sticky graph in there. Y to the sky. All right. Example number 4. Let's go ahead and graph. What do I want to graph? Let's go with y equals negative 2x squared plus 8x. How about minus 9? I hope. Oh, no, I better go plus 9. Can we switch that to a plus? I'm trying to do it in my head, you know. Okay, so first thing we have to do is find our vertex. Again, I'm going to remind you this is my A, my B, and my C. So I do negative B over 2A, or in this case, negative 8 over 2 times negative 2. So negative 8 over negative 4 is 2. I'm going to take that 2 and plug it in. So I have y equals negative 2 times 2 squared plus 8 times 2 plus 9. So 2 squared is 4 times negative 2 is negative 8 plus 16, so it's positive 8 plus 9 is 17. I guess I should have left it as minus 9, huh?
Negative 2 times 2.
No, you do your squared first. Times negative 2 is negative 8. This is plus 16. Right? So it's 8. Plus 9 is 17. It's going to put it off the graph. Do we want to change that back to negative 9? You guys okay with that? Sorry about that. I was trying to do it in my head. It didn't work out well. Put minus 9. My bad. Minus 9. Okay, so that's going to make it 16 minus 9. Or let's see. So 8 minus 9 gives us a negative 1. Does that sound better? All right, so we have a vertex at 2, negative 1. An axis of symmetry at x equals 2. So first I'm going to plot 2, negative 1. I have an axis of symmetry right here. Now before I get started, which way is this going to open up? It's going to open down. Very good. It's going to open down. I'm going to pick 2 points, so either the right or the left. So either I want 3 and 4, or I want 1 and 0. 1 and 0 sounds like a plan. So I'm going to take 1 and plug it back into my equation. So negative 2 times 1 squared plus 8 times 1 minus 9. So I got negative 2 plus 8 is 6, minus 9 is negative 3. Okay. And then I have negative 2 times 0 squared plus 8 times 0 minus 9. Gives me negative. Yep. All right, so let's plot those 2 points. I have 1, negative 3. So 1, negative 3. And 0 minus 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right there. So now that I've plotted those 2 points, what do? Reflect them. One's right here. And one's right here. And then I connect them. Any questions? No questions? Easy stuff? Nope, not any of these last ones we don't. I just want you to grasp.